Hi everyone, and welcome to this tutorial of using Orion software for design structures and analysis. So let's get started. Uh, First of all, you should have an AutoCAD file. So we'll design this simple structure by using Orion. First of all, we go to Save As. We have to change the extension of the AutoCAD file to DXF so that the Orion will import the file and we will use it. So from file type we choose DXF, save. Now let's go to Orion. I have version 18. It's a very simple software and I found it very easy to use. First of all, we go to select data folder. Let's take this folder and let's make new project. Okay, here you will choose your code. So I will use PS8110, and here this is about sheet data. Okay, from file we'll import the AutoCAD file from external reference drawing DXF load, and here is our file, the AutoCAD file. Open. The unit you will use must be the same unit that was used in your AutoCAD file. So I was using centimeter. Okay, this is my drawing. First of all, you must have axis lines so that you can put your columns and beams. So from axis, from this icon axis, you can generate your axis lines in this way. You go to the line start point and you drag it until the end. So this is the axis, as simple as that. Also one option, if you want to stretch this axis line, go to right click, stretch axis, just like this. I want to make offset here, like let's say 1 meter. So just like AutoCAD, offset. From offset you will here you will put your distance, let's say 100 centimeter. And the unit is in millimeter, I guess. Anyway, just to show you how, if you want to make offset, how to do this. So now I finished my axis lines, and let's put the columns. First of all, before you will put your columns, let's say this structure is designed for 2 stories. So from this menu, story menu, you go to insert story. The software will consider the first story is the plinth beam level. So if you want to design 2-story building, you should enter here 3, and if you are designing 3, you'll put the number 4, because the first story is considered the plinth beam level. So we'll insert here 3. Okay, now this is the plinth beam level. This is the first floor. This is the second floor. Now also, if you want to edit your story levels, the height, let's say the plinth beam level is, this is in millimeter, the plinth beam level is 1 meter. The first floor level is 4 meter, and the second level is 3 meter. And here you must enter your foundation depth. So let's say 2 meter. Okay. Now we'll put our columns. So from this icon, column, you can put your columns. Also, you can reach this from member, axis, column, wall, beam, everything. So we will choose column properties. This is the general properties, the dimension and everything. From here, this is material. This is not 0, this is the program default. So this is the concrete grade, and the steel bars grade. So I will just keep it as default. If I want to change the default, I will go to building analysis. Here, this is the parameter. So from material, I go to edit material, and I can change the grade, the concrete grades and the steel grades, for columns, for beams, for slabs, for foundation. So let's keep it the same. We'll go back to this. Now I can enter my column dimension. Let's say the depth is 500. This is the dimension of the section, and the width is 200, and this is my column. So you will see it's out of the wall, or if I want to shift it exactly here, this is the eccentricity. If my B1 is 500, so this E1, the distance from the center line to center of the column. Let's make it like this. No, this one must be 100, because the wall is 200 millimeter, 20 centimeter wall. So I want the center line in the center. This one, I'll put it 400. No, 100, like this. Let's say I want to rotate the column. I can just switch the depth and the width. So P2 is 500, so this E2 I will make it 400, like this. The same column here. I'm putting the columns randomly just for example, to show you how to design in this software. So now if I want to put the same column here, just click on the column and click on this icon, so the same properties will be copied here. I need to change the dimension again. So I want another column here, but I will rotate this column. Okay, save. Now let's put the beams. Let's put the beams from this icon, or you will go to member beams. So here you will have the general properties, and here you can change the concrete grade, the steel, the material, everything. I will choose the width 200 and the depth 500. So the depth is 50 centimeter. You can see that the beam is shifted out of the axis line from here. I'll put this 100. Now it's okay, and just you click on the start point to the end point, just like the axis, and you will construct your beams. Let's say we will make this beam 60 centimeter depth. That's it. So this is the plinth beam level. I will not put any slabs here, but for the walls, if we want to enter the wall loads, so we click any beam, right click, and from edit beam wall load, you will see this window. So here you can choose different tab of walls, but I will just enter the values manually. My wall unit weight is 3.8 kilonewton per meter. The wall height is we said that the first floor height is uh, 4 meter. So this is 4 meter and this is 0.2, the wall thickness, and the software will calculate this dead load automatically. Okay, you'll see that the color of the beam changed. You don't have to do this for all beams. You just right click, copy beam wall load, and by selecting all the beams, you can just right click again and paste copied beam loads. Yes, and that's it. Now I want to generate this structure to the first and second floor. So from the story menu I go to generate story. This story I want it to be generated to second and third floor. Okay, now if I go to second story, this is the structure. Now let's put the slabs from this icon slab, or you go to member slab, the same. This is the general properties. The thickness, let's use 160 millimeter. This is the concrete cover in centimeter. It's always in centimeter. The loads, the dead load, you can choose the values from here, like this: rooms, corridors, stairs. I'll choose the dead load 2 kilonewton per meter, and the embossed load is 2 kilonewton per meter. And just you click on the span, the slab will be constructed. Let's choose 180 for this. If I want to make the intersection on axis region, this means like this slab, only the axis, and this one, only this span will be constructed, the slab, not all the beam, not the slab inside these beams. So I wanted beam region. Something is wrong here. Yes, there was a mistake. This beam is not connected to the column because it's not to the center of the column. So that's why the slab was not constructed. So I will delete it and let's do it again. Okay, so if you click on any member, like I clicked on this slab, the same thing will be the same properties. I can just copy this slab here and here. So this is the second floor. The wall height up to the third floor is 3 meters. So let's change this. 3.8. Wall height 3 meter, 0.2, and copy to all beams. Paste. If I want to check the slab deflection, maybe this section is not sufficient, So I go to the slab strip and I just drag this strip across the slab, so it's sufficient for this slab. You see the deflection check insufficient, the section is insufficient, so I have to increase the depth or reduce the loads. Let's make the depth 200 millimeter. Update. If I do the check again, it's okay. Now let's generate this. If I want to generate these slabs to the third floor or third story, I can select it, or I can do another thing, generate story. I want only slabs, slab opening, only the slabs to be generated to this story. So if I go to the third floor, the slabs are generated. This is the roof, level. I don't want, there is no walls on the beam, so I want to cancel the wall load. You can just select all and delete beam wall load. Okay. So if I want to see my building in 3D view or 3D view, this is the building. By right click you can rotate or see around the building. If I want to go back to the 2D view, plan view, okay. Okay, so now let's start the analysis. First of all, you will go to finite element floor analysis, and from here you will choose include column section, include upper story column loads, and I will change the slab stiffness factor to 0.25, and then you click on floor mesh and analysis. So I will choose the uniformity factor, the maximum, and generate model. That's it. This is the finite element. Close this. It will start the analysis. This is for the third floor only. Then again you have to go to the second floor and you do the same thing. There is an easier way. You can go to the patch FE chase down and you can edit this, include column section from here. The stiffness factor I will choose 0.25, and the mesh uniformity 100, and okay. It will, the software will do the analysis for all floors. So this is the analysis results for the finite element, the maximum displacement. Okay, close. Now we go to the building analysis. So from analysis uh, I can click start, and here I can do the design directly. The software will analyze and do the design directly. So I click on this. If I did the analysis and then I change the structure, like I add beams or columns, then I want I want the software to redesign and reselect the bars. I can click this one. Okay, start. Okay, now the software is designing the column, the beams. Building analysis completed successfully. Okay, close. This one, the results of the analysis. If I want to see the deflection, displacement, diagrams, moments, shear. This is the animation, how the loads are affecting the structure. Anyway, close. Now if I want to see the designed columns, from run, column section, design. So this is the column 1 and the first and second and third floor, and this is the steel bars. If I want to see this column, this is the steel bars, six bars of 12 millimeter diameter bars, and this is the area of steel. This is the maximum load, maximum axial load. Okay, and this is the lengths, 8 millimeter diameter lengths, and the spacing is 125 millimeter. If I want to see the beams, let's say in the second floor, I want to see these beams. Right click, beam reinforcement design, and this is the beams in this axis 1. I will choose the bottom number 3. So this is different according to the code. Anyway, this is the bottom bars, this is the top bars, and this is the extra over support. Let's say I want to use here 12 diameter. I reduce the bar diameters, but then this bar is not sufficient. The moment here is more, so I will add another bar. So I wanted to make it the same, the top and the bottom level. Here I will put three bars of 12. Here 2 bars of 12. So you can change the bar diameter and the number of bars as you want. Okay, so this is the beam design. If I want to see the slab design, I go to the slab strip and just drag the strip across the slab. You will see here unit 27 bar of 8 millimeter diameter bars, each 200. This is the spacing, 200 millimeter, and this is the bottom bars, the top bars only here, only in this area, and here you need 27 phi 8, the spacing 200 millimeter. Okay, now we will move to the foundation. We want to design the foundation, so we go to this level, story 00. This is the foundation level. I will select all the columns and right click, insert pad base. I wanted all square, create square footings. Okay, the software now will create the footings. That's it. So you can see that this is the footing dimensions, 1.8 meter, 1.8 meter. If I want to check the steel properties, the depth is 400 millimeter, 40 centimeter. Properties, if I want to change the depth, the surcharge height, the allowable bearing capacity, and here this is the steel bars. I will use this combination calculate. This is the designed steel bars. In the XX direction, uh, 516, and the spacing is 250 millimeter, and the same in the YY direction. This is the loading data. Okay, so this is the assemble tutorial of how to use Orion structure. It's very simple program, and actually it has a lot of other options and facilities. Once you work on this software, you will see how large it is, and you can design any type of structure you want. So I hope you enjoyed this tutorial, and thank you for watching. See you.